Finally, some applications. Section 3 of this notebook corresponds to 6.3 of our textbook. The first example, which came from our textbook, is the easiest and the most straightforward. It goes like this. The intelligence quotient scores are normally distributed with a mean of 100 and a standard deviation of 16. If one person is selected at random, what is the probability that the selected person's IQ is between 90 and 125? You have to draw a normal picture around mu equals 100. That's going to be the middle. That's going to be the peak. And 90 is a little bit less than 100, so we have to start from a little bit left-hand side of 100 and then go over to 125, which is a little bit right-hand side. We have to have this kind of picture. We are looking for the area of this blue region from 90 to 125. And our aim is to get the z-scores for 90 and z-scores for 125, which corresponds to z1 and z2 for this green picture. And then you can look up the normal table and find out appropriate area by some calculation. Okay, that's the strategy. We have the picture. So let's go with the z-score computation. z1 equals to x1 minus mu over sigma. We have negative 0.625 and then 1.5625 respectively. And how do we get the probabilities? Well, let's just go over to negative 0.625, negative 0.6, and then, excuse me, it's a negative 0.625, approximately negative 0.63. So negative 0.63, it's going to be 0.2643 approximately speaking. Oops. Okay. And then for 1.56, look up this table, 1.56, 1.56, we have 0.9406, and then we subtract one from the other. 0.9406 minus the previous figure I forgot, and calculate. We are going to get the middle number. Here in my notebook, I use a little bit more accurate figure using mathematical computation. This is a little bit more precise figure than the one I got from the table, and this too is a little bit more precise figure. Subtracting one from the other, we get this value. But if you use the table and get this computation, that is, let me see, from the table, 0.9406 minus 1.6, 0.625, 0.26, 0.63, 0.62643. And then if you get this kind of value, let's finish the computation. If you got this one using the z-table, you will get full credit. This value, of course, is a little bit more accurate value because I used Mathematicus computation. But if you use the normal table and get the latter value, I will give you full credit. Let's go over to the next problem. This is going to be an inverse problem. The intelligence quotient scores are normally distributed with a mean of mu equals 100 and the standard deviation of sigma equals to 16, approximately speaking. Find the 33rd percentile, which means the probability that that this normal random variable x is less than a certain IQ value has to be 33%, 0.33. We are looking for this kind of picture. Less than a certain IQ value is 0.33. In standard normal case, after calculating the z-score and the probability of z less than this a certain value here where my mouse is has to be 0.33. In other words, we have to look up 0.33 from that normal table. Let's see, where is 0.33? 0.33, 0. Let's see, 0. No, this is 0.03, excuse me, I have to find out 0.33, looks like it's right here, 0.3300, so this corresponds to z equals negative 0.44, I think, yes, negative 0.44. Let's go back to the Mathematica notebook. And yes, negative 0.44. I used a little bit more accurate figure using Mathematica's computation, so I got negative 0.4399 something, and the figure I got from the z table is negative 0.44, which is pretty close. And from that z-score, we can find out x value. Z equals x minus mu over sigma. Solving for x, we get this. And then plugging in everything, we get this value, 92 point something. Or if you prefer, you can solve a numerical equation. Z equals x minus mu over 16. Well, I should have labeled everything as approximate equality because everything is approximation. And then that is approximately negative 0.44. Consequently, x minus 100 is approximately negative 0.44 times 16. Therefore, x is approximately 100 minus 0.44 times 16. Calculating all that, I'm gonna get 92.96, which is approximately 93. So the 33rd percentile of the IQ distribution is about IQ 93, assuming, of course, the normal distribution. Here goes an example of a backward problem. Next, let's talk about the third type of problem. This is going to be a little bit harder than the other two. The parameter estimation. The salaries of junior executives in a large corporation are approximately normally distributed. A pending cutback will not discharge those junior executives within $4,900 of the mean. If this represents the middle 80% of the salaries, what is the standard deviation? Information about getting discharged and things like those are not that important. Mean is not given. Within 4,900 of means, so within plus or minus 4,900 represent 80% of the salaries, and standard deviation is unknown. That's the kind of situation we are in. Let's begin with this picture, and kind of goes like this. The middle part should be 80%, 0.80. And left-hand side endpoint, right-hand side endpoint, from here to there, and we have to find out those z-scores. Okay, and then this one is mean minus this one corresponds to mean minus 4,900. Thus that one corresponds to mean plus 4,900. Another way to look at it is x minus mu is negative 4,900 and 4,900. That's another way to look at it. But that's still another way to look at it. We have mu, and this is mu plus 4,900, and this is mu minus 4,900. In any case, the middle part has to be 80%. Okay, that's the situation. And let's find out a z-score. How do you find out a z-score? Well, the probability is 80%. Using 80%, we have to find out the z-score, but be careful here. If you compare that picture with, let's see, picture from Mathematica, we have this middle part, versus picture in this normal table, either page 1 or page 2. Neither of them are the same. So how do we make it right? We shouldn't be looking at the middle 80%, but we have to look at one side, 10%. The lower 10%, this picture, if you focus upon this green region where my mouse is running around, that corresponds to shaded region of page 1. And consequently, we have to look at 10%, not 80%, not anything else, but 10%. So where do we find 10%? 0.10 0.1003. This is pretty accurate. Negative 1.28. Negative 1.28 looks good z-score. So negative 1.28 will give you this one. Consequently, the right hand side will be positive 1.28. So what do you get? Well, this kind of computation. X minus mu over sigma. X minus mu, what is the difference between this x where my mouse is and then mu? That's 4,900. 4,900 over sigma. That is my z value. And that has to be 1.28, approximately speaking. Well, here in my notebook, I used a little bit better figure than that normal table figure. In normal table figure is 1.28 only, but here I got a little bit more accurate figure. Well, more can always replace less, so a more accurate figure will be a little bit better. And solving for sigma, this is what we get, 4,900 over 1.28, 115, and then you get 3823.49, pretty accurate figure, or approximately speaking, you can say 3,820 or something like that. This problem did not specify rounding up to how many decimal digits, so anything will do. Okay, so much for applications. Among these, first two types of problems are really typical, and you should be able to do those kind of problems for any kind of distribution, not just IQ, but anything as long as you have mean and standard deviation. The third one here is a little bit trickier because neither the mean nor the standard deviation were given, but it was still possible to estimate the parameter, and that was an interesting problem. A little bit higher level, yes, but certainly something we can and should be able to handle.